Hello everyone. Today I'm going to discuss about the fundamental concepts of probability and different approaches how the probability can be calculated and what are the ways to measure the probability. So first we need to understand what is probability. So the probability is a numerical measurement of uncertainty. Sorry, I need to get back. Let me select the pen right here. So numerical measurement of uncertainty is known as probability. What do I mean by that? I mean by that something. Let us suppose I look outside the window, and somebody asks me what do you think, will it rain today? Then I look into the sky, I look into the arrangement of clouds. I might say that okay, there is a high chance it may rain today. I may end up saying that it's a moderate chance that it will rain today, or I may end up saying that it is a very low chance that it will rain today. Now all these chances, high, moderate and low, if can be assigned some numerical value, that numerical measurement is actually going to be the probability. So numerical measurement of uncertainty is probability. So if I draw it something like this, so what is probability? So something like that. So if this is the bar which is representing that my decision making or something. So if I say a high chance, so if I say okay, the shade is representing the chance that it may rain today. So if the shade is saying that I'm saying this is exactly the chance that it may rain today, yes, and this is the chance it is not going to rain today. If I'm moderately agreeing, so probably I am somewhere here, it may rain, may not rain. And if I am pretty, less enthusiastic about it, then I might say yes and no, it might rain. So these all measurements, high, moderate and low, do not have any numerical value as such. If I assign some numerical values to them, that numerical measurement of these things, that becomes the probability. So what is the uncertainty in this event? This much, this shaded portion is showing that I'm sure that it is going to rain. I'm certain. This is uncertain. Here UNC, and this is certain. Here this is certainty, this is uncertainty. Here this is certainty and this is uncertainty. So numerical measurement of this uncertainty is actually what is called the probability. That means if I manage to measure the uncertainty, that will become the probability. Let's go ahead, let's see how the probability is defined. So there is first definition, which is also called as mathematical or classical definition of probability. So you can read the slide, but number of outcomes favorable to A, number of exhaustive cases with respect to A. That means probability that A can happen is number of favorable cases divided by number of total cases. Now the challenge here is to identify what do you understand by number of favorable cases. So let me show you that how the classical definition actually works. Let us suppose there is a bucket in which there are 3 white balls and 4 red balls, and there is this person X who's standing here, and what I am trying to tell you is that if his name is X, somebody comes, blindfolds X and says that okay, if you're going to put your hand in the bucket and if you pick a white ball in first draw, I'll pay you certain amount. I'll pay you, let's say, $500. That's a game. If you do not pick out the white ball in first go when I blindfold you, then you lose the game. Might be you are paying it or not paying it, whatever it is. So let's see how this thing works. So if I talk about what is the probability that X wins, so how many favorable balls for him? There are 3 in numbers. Why? Because here if he draws a white out, then he's going to win. 3 are in his favor, but once he is going to draw first one ball, any of the total balls are how many? 7. Any of the 7 balls can come out. These are the total balls, right? So I'll say total. Any of the 7 balls can come out. So the probability that X is going to win is 3 divided by 7. which gives you a 0.42. If you multiply 0.42 by 100, that gives you a 42% chance that X is going to win, right? Now this 3 exactly and this 7 exactly, so many people get confused sometimes in calculating how this 3 and 7 actually comes when you apply combination permutation. So if you see these 3 balls, this can be any of these 3 balls, right? Any of these 3 balls. That means out of 3 white, he has to pick one. If you calculate it, it will be 3. Similarly, if you say the total balls, so out of 7 balls, any one can come out in one draw, and if you calculate it, it will be 7. So if I go technically, then it is actually 3C1 divided by 7C1, right? But the favorable cases are 3 and 7, so generally 3C1 is 3 if you read the permutation and combination, and it is very easy to understand. So this calculation of favorable cases and calculation of total number of cases actually comes from principles of counting. Principles of counting. And there are 3 principles of counting. One is multiplication, second is permutation, and third is combination. So that is about mathematical or classical definition of the probability. That how exactly the probability is calculated. Number of favorable divided by number of exhaustive. So it's nothing, it's just a ratio. You just need to understand how to calculate the favorable cases, how to count actually number of favorable cases, and how to count the number of exhaustive cases. Now the probability always remains between 0 to 1. That is also an important discussion. You know why? Because the maximum cases in the numerator could be 7, right? So 7 by 7 can maximum be 1, right? And there could be 0 favorable cases, so numerator can be either 0 or maximum 7. So in that case the probability can be either 0 or 1, between 0 and 1. I'm sorry. There is a relative frequency approach which is a little different from the classical approach. I'll be discussing it in next slide, let's say. So right now I'm going to stop the discussion here, the classical definition of probability. In my next lecture I'll be doing some questions on classical approach, and then in third lecture we are going to go with the relative frequency approach.